So we've learnt quite a few skills when it comes to dealing with probability distributions, whether it's discrete random variables, continuous random variables, binomial distributions, normal distributions, standard normal distributions. They all built up a set of skills, and now we're going to have a look at a whole bunch of problems that will utilize those skills to solve those problems. What I've got here in my notes here, just for you to have a look at, is the general approach or considerations you need to make. I can't do a video which will cover every single sort of problem you'll come across. That's not feasible. Instead, you need to be able to read through a problem and determine what skills are appropriate for that problem and apply them. I will go through an example though, so you can sort of see how it all comes together. Okay, so this second point is the one I wanted to really emphasize. It often uses a combo of these skills. Okay, so it won't be just a single skill that you've learnt. It'll be a combination of skills that will come together to solve a problem. Always, always, always support your working out with diagrams and tables unless it's provided for you or it really doesn't make sense in the context, but try and support your working out with diagrams or tables. And always, always, always make sure you answer the question. When it's a word problem, make sure you answer the question. Okay, here's a question that I have come up with. It is not the hardest problem in the world, nor is it the easiest problem in the world. I've chosen it to demonstrate how you can use combos of skills to solve problems. But keep that in mind, that you will come across problems that are more difficult than this. That's okay. All of them are solvable simply by reading the problem, breaking it down into the steps that you need to do in order to solve the problem, and using the skills that you have been practicing in order to do that. So let me read this example out. A species of fish is known to have lengths that are normally distributed, with mean length 22.7 centimeters and standard deviation of 1.4 centimeters. Well, that gives us already a sense of what this problem is going to use. I mean, we're told that there's a normal distribution, so we know it's going to use that set of skills that are applied to normal distribution problems. We also know that they're lengths, which is a continuous random variable. What do we need to find out though? Fish that are less than 20 centimeters long or greater than 25 centimeters long must be released if caught. Okay, we haven't been told what to do yet, but nevertheless, that's the information that we've been given. What is the probability that a caught fish can be kept? Okay, so we're catching a fish. What's the chances are that we can keep it? So first of all, we need to set up our random variable and we need to express our normal distribution. We need to model our normal distribution. So I might just change color just so it stands out a bit more. So we're going to say let x be the random variable of the fish length. Then x is distributed normally with a mean length of 22.7 centimeters, so it's 22.7, comma, and a standard deviation of 1.4, which means the variance is 1.4 squared. Note you don't have to work out what 1.4 squared is. You can just write it as 1.4 squared. In fact, one might say it's desirable to write it like that instead of as a different number. Okay, second thing we're going to do is we are going to work out what the diagram would be. So we have a normal distribution and we have a mean of 22.7. We have a minimum length of 20 and a maximum length of 25. And the area, the probability, is the area between those two values. So that's nice. We got that written down nicely. And so we need to work out P such that 20 is less than X is less than 25. In other words, x is between 20 and 25. Well, that shouldn't be too dramatic to work out. We are going to go to our calculator and put those values in, and we'll get an answer back. So we are going to use norm CDF with a lower bound of 20 and an upper bound of 25, with a mean of 22.7 and a standard deviation of 1.4. So that's our calculator operation, which I'll now put into our calculator. Menu, probability, distributions, and we're going to go for normal CDF. Lower bound is not negative infinity this time because we've got a lower bound of 20, an upper bound of 25. Our mean is 22.7 and our standard deviation is 1.4. And we get 0.9229, which I'm just going to write down, then I'll flick back to the whiteboard. 9229, and then there's a whole bunch of other decimal places. So that is the answer to our question. Okay. We could just go i.e. 92.29% chance. So we've got a pretty high chance of catching a fish that can be kept, which you would hope, I suppose. Alrighty, so that's a word problem. That's a solution.